Assalamu alaikum wa rahmatullahi wa barakatuh. Hi everyone, in a new episode for physics for IGs. Today, inshallah, we are going to speak about estimating and significant figures. Let's start by significant figures. Bismillah. First of all, the golden rule we have today that means all non-zero numbers always count. So all non-zero numbers are counted. The problem is in zero, we will, if it is in the beginning of the number or at the end of the number or in the middle of the number, all non-zero numbers are always counted. For example, 4.56 is considered as three significant figures. We have here three significant figures. The problem is with the zero. Zeros on the left are not counted. So here we have 0.0045. All the zeros on the left are not counted, and it is considered as two significant figures. The only figures we are going to count are 4 and 5. So it's two sig fig. If the zeros on the right, so actually, if we have a decimal point, it is counted, and we are going to count them as four significant figure because there is a decimal point. If there is no decimal point, here is the mystery. We have 4500. It's like a mystery or as you can say, ambiguous number that we cannot decide. Is it two significant figure? It is okay if I said it's two significant figure. If I said it's three significant figure, still okay. Four significant figures, also okay. But if, as I said, if we have a significant figure, if we have a decimal point, it means we are going to count all of them as significant figures. So 4.500 are four significant figure, this number. 6.02 times 10 to the power of 23, the scientific, here is the form of scientific notation or the standard form. The power of 10 are not counted at all. So actually we have three significant figure. 6.02 times 10 to the power of 23 considered as three significant figures. If there is in the exam, and this is a very important point, in the exam there is some problems will be given. The raw data will be within two significant figures or three significant figures, sometimes mixed between two or three significant figures. Don't take the number. The examiner plays with numbers a lot. They are so smart and they know how to play with numbers. They will give you simple numbers, and when you divide them or multiply them, it will give you a very big number as the number shown on the calculator on the left. You will see that it's very big. I'm not going to write the whole number. I'm going to check the raw data given in the problem. If the raw data given in the problem within two significant figures, so the answer must be within two significant figures. If it is within three significant figures, must be within three significant figures. If it is mixed, like one number within two significant and the other within three significant figure, and we learn it how to differentiate between the significant figures and the number of significant figures in any number. If it is mixed, we are going to take the least number of significant figures. Okay, so if it is 2 and 3, we are going to consider it 2. If you get confused and you don't know how to decide, work within between 2 or 3 significant figure. Most of the questions in the IGs are like this, within 2 or 3 significant figures. Okay, Ola? Now we are going to go to the estimation. You know, and sometimes we don't have the tools or the materials to make a measurements, and it will be very difficult. For example, if the examiner asked about the length of the room you are in, or your room in your house, the dimensions, the length, without you don't have the tools for the measurements, you are going to make an estimation, and this estimation must be a reasonable estimation with physical sense. Yani don't say it's like 60 centimeter or it's 46 centimeters, something like this, and it's like in meters. And when you are going to look to it, you need to imagine the length of the meter, or you can imagine the height of a person. We know the average height of a normal person is 1.7 to 1.8 meters. So I'm going to look like this. The height here is like two persons. So 1.7 times 2 will give us the height of the room. Or 1.5, the height of a person. 1.7 times 1.5, something like this. The length of the room, I can estimate it like this. So we need a reasonable estimation. The mass of 1 kilogram of apple. How many apples are there? Around 5 to 6 apples. So we need to have a reasonable estimation. So what is the mass of one apple? They may ask you about this. The meter rule. What is the mass of the meter rule? 100 to 200 grams. So we need to put a reasonable estimation, and sometimes it will not give you the data, a full data, and you need to make an estimation. For example, the average temperature of the human body, 37 degrees Celsius, 310 Kelvin. The mass of average human body, 60 to 80 kilograms. The height is 1.6 to 1.8. So the average height of the persons. Micro and macro world, you will see that the diameter of the human is about 70 micrometer, or 70 times 10 to the power of -6, or 7 times 10 to the power of -5 meters. The average speed of the car inside the highway ranges between 30 to 40 meters per second, which ranges between 108 to 130 or 140 kilometers per hour. So, and we know how to change between kilometers per hour to meter per second and vice versa. We studied it in the previous session. The thickness of a sheet of paper, the average estimation for a thickness of one sheet of paper is 0.1 millimeter. The atmospheric pressure, 1.0 times 10 to the power of 5 Pascal. The average estimation for, or it's actually the actual atmospheric pressure, 1.01, because here you have, it's not an estimation, it's like a measured value, 1.01 times 10 to the power of 5, or something around this. Okay, أولاد, I think we are done for today's session. It's short and dense, and I hope you enjoyed. Inshallah, we are going to practice solving past papers next session regarding to the first unit. We are finished with the first unit. Good luck and see you. Assalamu alaikum wa rahmatullahi wa barakatuh.